In our previous lesson video, we learned on cosine rule and we took 2 examples on it. But in this section, we are going to take more examples on cosine rule. So before we proceed, let's recall ourselves on the formulas of cosine rule. And we know that c squared is equals to a squared plus b squared minus 2ab cos c. Likewise, b squared is equals to a squared plus c squared minus 2ac cosine b, and a squared is equals to b squared plus c squared minus 2bc cos a. Now let's take just one question to refresh our memory on cosine law. So let's assume we have this question. Let's call it question 1. We have a triangle, say 5 centimeters, eight centimeters, and we have these angles to give us 46 degrees, and we are looking for x centimeters. Remember, cosine rule works when we have 2 sides and a related angle. So if we label this diagram to be A, B, and C, so we have length A to be equals to x centimeters, length B to be equals to 5 centimeters, and length C to be equals to 6 centimeters, with angle A to be 46, and we are looking for A. So let's just apply the formula of A, and we have a squared is equals to b squared plus c squared minus 2bc cos A. Simple as ABC. So with that, let's make our substitution. Our B is 5, our C is 8, minus 2 into 5 into 8, and the angle of A 46 degrees. So we have a squared. So with this, we will just have a squared to be simplified to 33.424. After we have made our substitution of cos 46 degrees to be equals to 0.6947. So with this, we have A to be equals to the square root of 33.424, and we would have it to give us 5.781 centimeters. So yes, we have refreshed our memory to have the value of A, which is also equals to x. Now, what if we are asked to evaluate an angle? Okay, we are asked to evaluate an angle in the cosine formula. So let's look at it together. C squared is equals to a squared plus b squared minus 2ab cos c. How do we evaluate the angle in this case? So evaluating the angle in this case now, we move a squared plus b squared to the left hand side. So we have c squared minus a squared minus b squared to be equals to minus 2ab cos c. So let's divide both sides by minus 2ab, divide both sides by minus 2ab, and the resulting numerator will have minus c squared plus a squared plus b squared divided by 2ab because of this negative, and there we'll have cos c. So the resulting cos c, as we can see now, will be equals to a squared plus b squared minus c squared divided by 2ab. Now if we have cos c to be equals to a squared minus b squared minus c squared divided by 2ab, we can also have the expression of cos b and also the expression of cos a. Therefore cos b will be equals to a squared, this is plus, so therefore b squared will be a squared plus c squared minus b squared divided by 2ac, and cos a will be equals to b squared plus c squared minus a squared divided by 2bc. Now if we proceed further, we can now use the formula we have in our inverse trigonometric function, where we remember that x is equals to, or let's say cos x is equals to, this is sine, Sine x is equals to a, and x will be equals to arc sine of a cos x cos y is equals to b, and we will have this to give us pi is equals to arc cos of b, and tan z is equals to c, and z will be equals to arc tan of c. So we will apply the rule of cos to these three, and we'll be able to evaluate the angles of A, angles of B, and as well as the angle of C. So let's take a quick question on how to evaluate an angle. Given we have this triangle of 8, 5, and 11 as the sides, and we are asked to evaluate, let's label it A, B, and C. We are asked to evaluate angle A. So this A, let's just call it alpha. Now, this is very interesting. So all we just have to do is to label the sides and see that this is A is equals to 5, B is equals to 11, and C is equals to 8. And we're looking for angle A, which is tagged as alpha. So we'll use the formula that results in cos A. So that formula involves using cos A is equals to B squared plus C squared minus A squared divided by 2BC. Moving on, we can now make our substitution. So we can have cos A. A in this case is simply alpha. So we have cos alpha is equals to B, which is 11. 11 squared. C is 8 plus 8 squared. A is 5 minus 5 squared. All divided by 2 into 11 into 8. So let's make our solution. 11 squared is 121. 8 squared is 64. And 5 squared is 25. 2 multiplied by 11 multiplied by 8 will give us 176. This is for cos alpha. So we are still on cos alpha, and cos alpha will give us 121. The numerator 121 plus 64 minus 25, which is 160 divided by 176, which is equals to 10 over 11. And in decimal places we have 0.9090, or let's say 91. Now if we have cos alpha to be equals to 0.9091, we can evaluate alpha by using arc cos of 0.9091, and using this we'll have our expression of angle alpha to be simplified to, in two decimal places we have 24.62 degrees. Now we might be asked further to, let's say, simplify the angle of beta, that's angle B. So all we just have to do is just use the expression of cos B to be equals to A squared plus C squared minus B squared divided by 2AC. So let's implement that. Cos B. So this is the first question. Second question. So we have cos B to be equals to A squared plus C squared minus 2AC divided by 2 minus B squared divided by 2AC. So let's make our substitution now. So B is beta. So cos beta, our A in the question, is equals to 5 squared our C in the question is equals to 8 squared, and B is 11 squared. Divided by 2 into 5 into 8. So we have 25 plus 64 minus 121, all divided by 2 multiplied by 5, 10 multiplied by 8, and that will give us 80. And this will result into minus 32 divided by 80, which is equals to minus 0.4. Now, if we take the arc cos of negative 0.4, cos beta is equals to minus 0.4. We will have our answer of beta to give us arc cos using our calculator 0.4, and we will have 113.58 degrees beta. So yes, this is for beta, and you might also be asked to evaluate for gamma. You will have the same results. You can try that using cos C, or let's say cos A. That should be cos C. So be equals to b squared plus a squared minus c squared divided by 2bc, and we will have our answer of gamma, as the case may be, to be equals to 41.8 degrees. Try it, I believe you get the answer. And now let's take an exercise on cosine law. But before then, let's take a quick recap on everything we have learned on cosine law. The first thing we learned was the formulas, that c squared is equals to a squared plus b squared minus 2ab cos c. Similarly, b squared is equals to a squared plus c squared minus 2ac cosine b, and a squared is equals to b squared plus c squared minus 2bc cos a. And we can simplify further to evaluate the expression of cos a, cos b, and cos c. Therefore, we are saying that cos a will be equals to b squared plus c squared minus a squared divided by 2bc. Cos b will be equals to a squared plus c squared minus b squared divided by 2ac. Cos c is a squared plus b squared minus c squared divided by 2ab. And with this, we can evaluate both the sides and the angle. Now let's take the exercise.